everyone, welcome back to the Intermediate Machine Learning course part 4 by Life Changes Academy. So far we have learned about the how to prepare data, different machine learning algorithms and how models make the prediction. But here is an important question. Imagine you have spent hours building a machine learning model. You trained that model, you tested that model, everything looks perfect. But how do you actually know whether your model is good or bad? Can we simply trust that model or should we test it first? That exactly we are going to learn in this complete session. Okay, so in the today's session we will be completely learn about the model evaluation and some of the important performance metrics used by the data scientists all around the world. Okay, so without any delay we will start this session. Okay, first of all we are going to learn about the model evaluation. Okay, guys, just to imagine you are a teacher. Okay, your students have finished writing an exam. Will you simply look at the answer sheets and say everyone passed? Of course not, right? What you will do, you will be check each and every answer and then you will be finding the mistakes and then you will be putting marks for each and every question and then you have to calculate the mark and finally you will be decide how well each student performed in the particular exam. Okay, machine learning also works on the same way, that is exactly the same way. After training a machine learning model, we don't immediately start using it. First we are going to evaluate the model. We are going to testing the model. Okay, so in simple words I'm saying model evaluation just means checking how well our machine learning model performs on new unseen data. This is nothing but it's like a model performs well only on training data. We already know, learn from the data concept. Learn from the data concept means we are already giving some data to the particular model. It will be learning the data and then it will be providing a particular output. Giving a accurate prediction to the model. That's not enough. When you are entering a new data, new image or else new video means that also it will be able to answering the particular new data also. Okay, new data also going to know by the model. Okay, it will not say that it didn't know like that. Okay, that's only because it will be perform well only on training data. It's enough. It should also perform well when new data also comes in. Okay, so that's the real test I'm saying. Okay, so I'm asking why do we using this model? So what's the purpose of evaluating this model? So there are four main reasons. The first one is measuring the accuracy. So measuring the accuracy is nothing but it tells us how accurate our predictions are. Okay, and the second one is finding the errors. It is nothing but it tells us it helps us to identify the mistakes. That means it helps us to identify the errors in the model. And then third one is compare models. It is nothing but it allows us to compare different machine learning models. And then final one is the improve performance. Okay, so it is nothing but it will be help us to improve the model until we get the best possible performance. Okay, so guys, I will say simple example for the model evaluation concept so that you guys are very familiar in this concept. Okay, for example, you are going to buy a new mobile phone. Okay, just imagine this one. Okay, so the shopper will be provide you some many brands of mobile phone like Oppo, Redmi and then etc. Okay, so first he will be choosing a Oppo mobile on the desk, but you don't buy the first mobile phone. You will see, right, you will be comparing the camera, comparing the brand, comparing the camera, comparing the model, as well as comparing the battery performance and then price also, right? So after the comparison, which one suits for you will be decided by you, right? Okay, this mobile is affordable for me, this is okay. So the decision will be based on the comparison only, right? Only then you will choose the best one. Similarly, only data scientists also comparing multiple machine learning model before selecting the final one. Okay, so this is how the model evaluation concepts go through the data scientist evaluations. Okay, so next we are going to see the important concept, that one is the accuracy. Accuracy, this word we already hear in mathematics, right? It's like a mathematical term, accuracy. Okay. Let's start with the simple and most popular evaluation metric. This one is the accuracy. Okay. Accuracy is nothing but it simply answers one question. What's the question? You guys all know? Okay, I'll say that question. Okay. So, out of all the predictions, how many were correct? Okay. I will explain. Okay. Don't get frustrated. I will explain. Let's understand this with a simple example. Okay. So imagine a teacher or else, okay, a teacher, she will be checked, she will be corrected 100 exam papers, okay. So out of 100, 90 students are passed correctly according to the answer keys, okay. According to the answer key, 90% of the students are passed in the class. Only the remaining 10% students were wrong. They mean they were failed in the exam. Okay. So here, what is the accuracy? How you say accuracy? Very simple. 90 correct predictions out of 100. When some teachers, how the teacher put a mark 90 by 100, right? That is the accuracy. 90 correct predictions out of 100. That gives us 90 percentage of accuracy. I hope you learn this. You will get this point, right? Yes. Okay. The higher the accuracy, okay, the value which will be in higher, that one is the accuracy. Not the 10% persons who are failed is not an accuracy. The person who are 90% pass mark, the person will get no. So that person's or that mark, that total will be the accuracy. Okay. But here is the one important problem here. The accuracy doesn't always tell the complete story. Okay, let me show why. Okay, so guys, you just imagine that a hospital. Okay, in a hospital is testing people for a very rare disease. Okay, like recently we will having a coronavirus. Okay, it will some rare disease only, but many of the people suffer so hard, right? So likewise, some hospital people is going on testing because of some rare diseases. Okay, there are approximately 1,000 people in the hospitals. Okay, so everyone is checking that whether they have the rare disease or not. Okay, so within that in the report will be said that 990 persons who are testing for the rare disease will be healthy persons. Okay, the 990 person will be safe, they are healthy, they are not having any disease. The remaining, the 10% persons are affected by the rare disease. Okay, now imagine our machine learning model simply predicts everyone is healthy. Okay, what happened here? It correctly predicts 990 people only. Only the 10 predictions were wrong, right? That means the model has 99% accuracy. Okay, the higher value will be termed as the accuracy. Sounds amazing, right? Yes, but think about it. Okay, so next we are going to see the accuracy concept, the model which are failed to detect every single patient who actually had the disease. Okay, can we call this as a good model? Definitely not, right? This is why accuracy alone is not enough. Okay, that's where precision as well as recall became very important. Okay, so what's the use of precision? We will be seeing in the upcoming session. Okay, so we will be going to see precision here. Okay, precision. Precision is also an mathematical term, right? Okay, precision answer this question. Which question means whenever the model say yes, how often is it actually correct? For example, guys, imagine Gmail, okay, Google Mail, okay. It marks 20 email as spam, but after checking, we find that only 18 were actually spam. The other 2 were important emails. So, out of 20 emails predicted as spam, 18 predictions were correct. So, that gives a precision of 90%. Okay, a model with high precision makes fewer false alarms. Okay, that's why precision is very important in applications like spam detections, fraud detection, as well as medical diagnosis. Okay, so precision is nothing but it will be whenever the model is positive means how often is it correct. It will be testing that conditions. Okay, so think of example as a Gmail. Okay, so that only will understand the concepts clearly. Next we are going to see another concept. That one is a recall. Recall is nothing but it will ask a completely different question. That means out of all the real positive cases, how many did we actually find? Okay, let's continue with the Gmail example. Okay, so that only you will connecting these two, precision and recall. Okay, the examples also connected, the concept also connected here. Okay, so see here, 10 spam emails entered in your spam folder. Okay, that means the model missed 10 actual spam emails, so the recall becomes the 90%. High recall means the model misses very few important cases. That's why recall is extremely important in the healthcare. Okay, healthcare means in the hospitals. Okay, would you rather miss a cancer patient, or would you accidentally ask one healthy person to take another test? Most doctors prefer not missing patients. That's why recall became more important in precision in the medical applications. That means in a medical services, medical diagnosis. Okay, so I will give some difference between the precision and the recall. A little glance so that you will be understand easily. Okay, I have one doubt. Which one is better, ma'am? Whether the precision or else recall? The answer is it depends on the problem. Okay, so it will be depends on the problem. If false alarms are expensive means we will be prefer the high precision. If missing an important case is dangerous means we will be preferring the high recall. Okay, this is no universal winner. Okay, the both are common. Depending on the problem only we will be choosing that particular precision or else recall. Okay, we will be choose the actions. Okay, next we are going to see F1 score. So what if we want both? So, okay, ma'am, I want both precision as well as recall means what will you do? That's exactly F1 score was created. Okay, the F1 score, it will be going to combine both the precision as well as recall into a single number. Okay, think of it like a judging a cricket player. Would you judge only by batting? No, right? Would you judge only by bowling? No. A true all-rounder performs well in both, right? Similarly, the F1 score rewards machine learning model that perform well in both precision as well as recall. That's why data scientists often use this F1 score. Okay, especially when working with imbalanced data sets. Okay, they are using the F1 score. Okay, it will not having only the precision, it will not only the recall, it will have both one. Okay, so that only F1 score is always used by the data scientist. Okay, next we are going to see something interesting. That one is a confusion matrix. Okay, so confusion matrix means imagine just you are working with the Google Mail. Okay, your job is to separate mails into two folders. One folder is a spam, another folder is a not a spam. Okay, sounds easy, right? Yes, but sometimes the model makes mistakes. Some spam emails go to the inbox, and sometimes the important emails are wrongly marked as spam. So instead of just saying the model is 95% accurate, we want know that exactly what kind of mistake it is making. That's where the confusion matrix help us to relieve from the problem. Okay, so here I will given four important outcomes. Okay, one is a true positive, and then is a true negative, and then false positive, and then false negative. Okay, so first we are going to understand what is a true positive. Okay, suppose an email is actually spam. Our model predicts spam. Okay, perfect. Okay, the prediction is correct. Okay, this is called true positive. Okay, and then true negative means, now imagine an important mail from the company. Okay, from your company, an important mail will be sent by your HR. Okay, or else your team lead. Okay, the email is not spam. Okay, but our model also says not spam. Again, the prediction is correct. That is the true negative. Okay, and then false positive. False positive. Now let's see a mistake here. Okay, suppose your manager sends an important office email. Okay, but Gmail marked it as a spam. Okay, the email was actually not spam, but the model is treated as spam. Okay, this one is the false positive. Okay, in simple words, it's like a false alarm. Okay, the model thought there was a problem, but actually there is no problem. Okay, that one is a false positive and then false negative. Okay, now imagine the opposite situation. Okay, a dangerous phishing email enters your inbox. The model says this looks like a safe. Okay, but in reality it was a spam. This is called a false negative. This type of mistake is usually much more dangerous. Okay, because the model failed to detect the actual problem. So why is the confusion matrix is important here means, so why do data scientists love the confusion matrix? Because accuracy tells us how many predictions were correct, but the confusion matrix tells us where the model is making the mistakes. Okay, it's like a cricket scorecard. Knowing the final score is useful, but knowing who scored runs, who got out, and who took wickets gives us a much better understanding of the match, right? Similarly, only the confusion matrix also give a complete picture of our model's performance. Okay, I hope you understand this concept. If you are going to see overfitting, I already explained what is overfitting, right? Now, guys, just you imagine you are going to prepare an exam. Okay, instead of understanding the concepts, okay, you simply memorize every answer from last year question paper. That's the thing we do in our exams, right? So okay, on exam day the teacher gives completely new questions. Okay, now what happened, you feel more frustrated and then you will be getting struggle to answer those questions, right? Because you memorize the answer instead of understanding the concepts. This is exactly what happens in overfitting. Okay, so the machine learning model memorizes the training data. It even memorizes small mistake, random noise, unnecessary details. Okay, so during the training period it performs amazingly well, maybe even 100% accuracy. But when completely new data arrive means its performance suddenly drops. It will be went down. Okay, it fail, but it never truly learn the pattern. You just memorize the examples alone. Okay, so some real world example I am saying for overfitting. Imagine teaching a child to identify a dog. Okay, only you show picture of white dog. After learning, when you show the black color dog, the child says this is not a dog. This one, the white color only dog, the black color is not a dog. Likewise, only the child says, right? Why? Because means the child memorizing the training example instead of understanding what makes a dog. Right, a good machine learning model should recognize the dogs of different colors, different sizes, also different breeds. Right, that's why overfitting is a problem. Okay, okay, next one is the underfitting. Okay, underfitting is also one concept. Okay, underfitting, good fitting versus overfitting. Let's look at the opposite problem. That is one, the underfitting. Imagine you have a math exam tomorrow. Okay, but today you studied only for 5 minutes only. You skipped most of the chapters. You didn't practice any problems. Will you perform well? Absolutely not. Right. Why? Because means the exam is not because the exam is difficult, because you didn't learn enough to crack the exam. Right. That's exactly what underfitting means. The model is too simple. It doesn't learn enough from the training data. As a result, it performs poorly during the training and it also performs poorly on the new data. In simple words, it misses the important patterns. Okay. That one is the underfitting. Good fitting is nothing but it's like a, it will be just right, learn useful pattern and generalizes the well. Okay, so good fitting, now we have two problems. Okay, one model memorizing everything and another model learns almost nothing. Right, what we do means we want to good fit Think about learning to ride a bicycle. If you memorize only one road, you will struggle everywhere else. If you never practice means you won't even know how to ride the bicycle, right? But if you understand the balance, like braking and then turning, we can confidently ride on different roads, right? That's exactly what a good fit model does. It learns the important pattern without memorizing the unnecessary details. It performs well on both training data and completely new data also. So good fit is also just right concept. Okay, so I will give a quick comparison between three underfitting. Okay, underfitting is nothing but it's like a too simple model. Okay, it misses the important patterns also, and then it provides the poor performance everywhere. Okay, and then good fit. Good fit means the model learns the meaningful patterns. It performs well on both training as well as new data. That is our goal, right? And then overfitting. Overfitting is nothing but this model becomes too complex. That means it memorizes the training data, excellent training performance, poor real world performance. But always remember one thing: we don't build machine learning model to impress the training data set. We build them to make accurate predictions on data they have ever seen before, right? So you will go through these three methods. Okay, so that's all. So thank you guys for watching this video. I hope you understand these concepts clearly. This is also one of the important concepts also. Okay, so these concepts are widely used in every machine learning project and all. Okay, so make sure you understand them very well before moving forward. Okay, and then thank you so much for watching this video. I will see you in the next advanced level video. Okay, so that until then, keep learning, keep growing, and keep building with Life Changes Academy, and then also keep exploring the amazing world of machine learning. Okay, so guys, thank you so much. See you in the next video. Bye.